Yes. Okay, good morning to all. Today we are going to look at 8085 microprocessor. So before getting into the topic, I just wanted to get answers from you people. What is 8085 and what is 8086?
Ma'am, 85 is 8-bit processor, ma'am, and 86 is 16-bit processor.
Excellent, super answer. Very good. And anyone from girl side, is there any other difference between 85 and 86? Can you just precisely tell me the answer? Girl side? No girls in the class?
Ma'am, address bus size, ma'am.
Addresses and buses.
8
Okay.
16 bit, 808 20 bit, ma'am.
Excuse me? What is Sunaba?
Ma'am, 808 8 to 16 bit, ma'am. 808 20 bit, ma'am.
Address lines. Very good. Super. Sounds good. Okay. This is the basic difference between 85 and 86. Okay. So the data lines present in 85 is 8 bit and the data lines present in 8086 is 16 bit. Right. So this is your basic difference and the address lines of 85 is A0 to A15. Okay. அதில் வந்து பார்த்துட்டேன்னா உனக்கு A0 to A19 you will have more address lines in your 8086 20-bit address lines in the 16-bit address lines, right? So this is the basic architecture of 8085. So we have interrupt control, serial input output control, accumulator, temporary register, flag register, instruction register, arithmetic logic unit, instruction decoder and machine cycle encoding, timing and control, and we have some registers, stack pointer, program counter, increment decrement latch, address buffers and data buffers. Okay, we have already seen this architecture in the previous session. Okay, I'm moving to the next one, that is pin diagram of 8085. So this is your pin diagram of 8085 40-pin IC. So dual inline package, which means we have pins at the either side of my die. Okay, IC la I have both sides, I have pins, so this is called dual inline, and we have multiple function pins over here. What do you mean by multiplexing or multifunction pins? So multifunction or multiplexing is said to be a combination of one or more. Okay, so from this diagram you can easily understand that A and D are coupled with each other. So which means A address and D data will be together. In order to get individual data and address, we have to give some control signals, which is nothing but address latch enable. So this is the pin which controls to separate your address and data in multiplexed pin or multifunction pin. Okay, so other than that, we have single functions in all the pins, individual pins. As you can see here, we have A alone, which means address alone passing in this particular 28 pin. Likewise, we have SID, SOD, serial input, serial output, everything are individual in IC. Okay, so there is no multiple function other than A and D in 8085. When you go for 8086, we have multiple multifunction pins in pin diagram. Okay, so why we are going for multiple or multiplexing or multifunction means in order to reduce the size and the number of pins in the die. Okay, say for example, if I want to put all the pins in individual, all the functions in individual pins, then I should go 8 pin extra. Okay, 8 pins extra vanduchuna, which means it obviously enhances or it obviously uh, enlarges the size of the die. Okay, so say for example, if you take this IC, particular IC is in some 5 centimeter, 5 centimeter or 2 centimeter, say for example, or 1 centimeter IC. Okay, if I go for 8 pins extra, then the size of the die will be 1.3 or 1.2 centimeter large. Okay, that should not be recommendable for any electronic applications. So the size of the eyes should be lesser, smaller when days goes. Okay, so this is the particular reason for going for multiplexing. And next comes the ALU internal structure. Okay, as we have seen in the architecture, we have multiple registers, accumulators, flag registers, timing and control, decoding, everything. Okay, that is what given over here. We have 8 bits data, registers and accumulator. What is the function of accumulator? Whatever the process done by your processor, the result will be stored in the accumulator by default. Okay, so by default the result will be stored in the accumulator. Then only we have to get back the data to some other memory location. Okay, the default result will be in accumulator, whatever the application done by your processor. And next we have perform arithmetic and logical operations using ALU. And next we have test for conditions if and then, and sequence the execution of instructions. Store the temporary data in RAM during executions. So these are all the functions performing by your 8085. Okay, first of all, it stores the data and it performs arithmetic logical operation. It tests the condition whether we have any condition in the program or not, and it execute the instructions sequentially and store the data in the RAM. Simple. This is as simple like that. And next comes your internal structure. So here we have accumulator, flip-flops or flag register. So flag register application is showcasing the status of the particular processor application. Okay, so currently what your processor will do, the status of that application or process will be executed in the status register. Okay, so here we have ALU. This is internal structure of your 8085 microprocessor. This is your internal data bus. Okay, and this is instruction decoder. So instruction decoder is nothing but it tells the microprocessor what the exact instruction is in the program. Say for example, if I go with SUM A comma B, that is sum A comma B, this will not be understandable by the microprocessor. What exactly the instruction decoder will do is, it converts the instruction into hexadecimal and into the binary, that is machine language, so that the machine will understand, oh, this is what the instruction, this is what I'm going to execute, I have to take them into action. Likewise, this is the performance of instruction decoder. Okay, எந்த இன்ஸ்ட்ரக்ஷனை எப்படி பண்ணணும் அப்படிங்கறது இந்த இன்ஸ்ட்ரக்ஷன் டிகோடர் வழியா தான் எனக்கு ப்ராசஸருக்கு போகும். டைரக்டா ப்ராசஸர் will not understand what is your instruction. Okay, so this helps to decode your instruction. And next comes we have control unit. All the control signals passing over this control unit. Okay, say for example, read, write, memory, input, output, reset, all these things are control signals of doing applications. And next here we have the same registers B, C, D, E, H, L. All are 8-bit registers, stack pointer and program counter. The thing which we have seen in the architecture is given here as internal structure. And the registers, okay, already we have seen, right? So here we have 8-bit bidirectional lines. Here we have 16 lines, that is unidirection. Okay, because it possesses only addresses. It possesses only addresses. So we have D0 to D15 in my 8085. That is address lines of 8085 is A0 to A15, and data lines will be from D0 to D7. That is why the data are bidirectional over here. I can put and retrieve the data whenever I want, but addresses shall not be like that. It is unidirectional. Okay. And next, the internal structure, registers and accumulator. Okay, what are all the registers available in the architecture? As we have seen, B, C, D, E, H, L. These are all general purpose registers. Okay, So general purpose registers are B, C, D, E, H and L. Each carries 8-bit. And they can also be combined like 16-bit operation. If I have an 16-bit data to perform by 8085, I can combine my register B, C, D, E, H, L like that. Okay, that provision is also available in 8085. And we have registers like accumulator, temporary register. Okay, so here accumulator is a 8-bit register, is a part of ALU. Okay, we cannot ignore this accumulator. It should be there. This is a vital thing in architecture because it has the capability of storing the data, that is result. Okay, storing the result by default. Okay, used for arithmetic logic operation, the result is always stored in the accumulator. Okay, whatever the processor you go with, the accumulator will store the result. Okay, and next comes the program counter. We have already explained. So program counter, it counts, it is used to control the sequencing of execution, and this is used to hold the address of the next instruction. I told you, no. So this is program counter. It is counting one by one. Say for example, you have 10 lines of program. Okay, so you have 10 lines of program. A program will be stored. You have 10 lines of program. Say this is 1, 2, 3, 4. Okay, say for example, we have 10 lines of program here. Your program counter, what it will do is first it counts the first initial address. Okay, say this is your 1000. Initial address will be 1000. And after executing this particular instruction, it moves to the next one. Okay, so the instruction will be say no, no, a, this is a, okay, a, comma, b. Okay, this is the instruction which moves the content of b to a. So likewise, it will move from b content to a content accumulator. Okay, after executing this first line of instruction, your program counter will move and increment by 1 to the next location. Okay, it has address of 1, say 0, 0, 1. Okay, the instruction will be sum a comma b. A comma b. Okay, in this instruction, what a processor will do is it is going to add two numbers which is present in the register A and B. Okay, so already I have taken, or I can transfer the data from B to A. What is there in the B? Say I'm going to add 2 plus 3. 2 plus 3. What is the result? The result will be, what is 2 plus 3? 2 plus 3 is equal to 500. Okay, so this is in present in your A or B. Okay, I'm going to take two registers. I'm going to add these two numbers with the help of the register A and B. Okay, final results will be stored in accumulator. Okay, in this case, I'm going to move the data content from B to A. Okay, so if you take a single data, say 2, without 3. If you take a single data, this is present in B, I'm going to move this 2 data to my accumulator. Okay, so what happens? The copy of data will be moved from B register to accumulator. Copy of data only moving. Okay, not the exact data or not vanish in the B register. The 2 is remains the same B register as well. Now I'm going for the next instruction as sum A comma B. So that is why the data present in B register is moved towards A. A has 2 now, as well as B has 2 now. So 2 plus 2 is equal to 4. The 4 result will be stored in the address, I mean accumulator address. Okay, so 4 will be stored in accumulator. So this counting of program will be done using your program counter. Okay, right. So this is next is what program counter will do all these operations. And next we have stack pointer. It is also used to put the data last in first out fashion. It is 16-bit and it can able to store the data with the help of push instruction and retrieve the data with the help of pop instruction. Okay, this is stack operation, stack pointer. Stack pointer always points to top of the stack. Empty stacker it represents, right? And next comes we have general purpose microprocessor that address 64K byte of memory. What is the memory capacity of memory capacity of 8085? So the memory capacity of 8085 is 64 KB. Okay, and we have 40 pin IC which is having a power of plus 5 voltage. Okay, and nowadays you can see the most probably the launching pads are working with 3.3 voltage. Okay, low power consumption. So this is an added advantage to the updation version of microprocessor. 5 voltage is consuming more power, isn't it? So if you go for 3.3 voltage, say for example MSP 430 or some launching pads like Arduino, okay, or Raspberry Pi, all these processors or launching pads will work with low power energy. That is 3.3 voltage is sufficient to work with. Here it requires 5 voltage plus 5 voltage of power and the frequency is 3 megahertz. Okay, so what do you mean by frequency? Can anyone tell me what do you mean by frequency? What is frequency? Gayatri, are you here?
Yes, ma'am.
Yes, Gayatri. What do you mean by frequency? Have you heard the term frequency before?
Yes, ma'am.
Yes. What is frequency then?
Repeated event of something, ma'am, like a signal.
Repeating signal.
Yes, ma'am.
Right. Very good. Sounds good. Good answer. Thank you, Gayatri. And your frequency is nothing but this is your x-axis and this is your y-axis. Okay, the signal which keeps on repeating is said to be frequency, continuous positive and negative cycle. This is your frequency, correct? So f is equal to 1 by t. You all know f is equal to 1 by t. In the reciprocal of your time gives your frequency, or reciprocal of your frequency gives your time of the particular signal, correct? This is your frequency and time relationship. Okay, so in this processor we are going to give frequency signal in order to execute the instruction. Okay, this processor will not have inbuilt clock signal or inbuilt timing signal. Okay, I should go for timing signal to execute any instruction. Without my clock signal my processor will not work. Even I have given input like plus 5 voltage and ground, this will not execute any single instruction. Okay, only after the application of clock signal only the processor will get into action. It will execute the instruction, right? So here we are going to give the clock signal in the type of square pulses. Okay, not in the sine waveform, it is square wave. Okay, that is what the clock pulse is. So this is your clock pulse of 8085 or 8086, whatever the processor you are going to use. Okay, this is your clock signal. Right. So the frequency of that particular clock will be 3 megahertz. Okay. So this frequency is enough to execute instructions in 8085. But this frequency will get varied depending upon the processor. If you take 8086, the frequency of processor will be 5 megahertz of frequency. Okay. What happens when the frequency is increasing or decreasing? We know frequency is responsible for executing any instruction, correct? You all understand that point, right? So now tell me, what is the difference in increasing or decreasing the range of frequency for individual microprocessors? Ranjana, Shri Ranjana, Sanjana.
Yes, ma'am.
Sanjana, what is the need of increasing the frequency in microprocessors? Why don't we use 3 megahertz for 8086? I told you for 8086 the frequency range is 5 megahertz. Okay. Why we are increasing the frequency? Any idea?
No, ma'am.
No. Say okay, right. And Hari Niklesh. Are you here, Hari? Where is he? Hari. Karthikeyan? Yes, Karthik. Yes, Karthik. Yeah. You are audible. Okay, Karthik, can you tell me the frequency definition or something else related to frequency? Generally, what is frequency? I have explained you here with the diagrams, right? Nothing wrong. If the answer is wrong, I'll make you right. No problem. Come on. Karthik? Karthikeyan? Okay, let me continue. The frequency of 8085 is k megahertz. Okay, so this is the frequency to execute the instruction. Okay, why we are going for higher frequency is so. Let me explain with this diagram. I'm going to get a set of programs. Okay, so each program at least having 10 lines of instructions, say for example 10 lines of instruction, right? So first instruction will be executed in the first clock pulse. We have started pipelining operation, right? Fetch, decode, execute and write. 4 operations, 4 clock cycles. Do you remember all that? Okay, pipelining operation, fetch, decode, execute and write. Okay, 4 operations will be performed in pipelining structure and it requires clock signal, 4 clock signal. Okay, what is clock signal? That is a square pulse. This is called your clock pulse. Okay, so I'm going to execute one instruction with 1 clock pulse. Okay, then what happens? I am going to execute the second instruction, the second clock pulse. Likewise, 10 lines requires 10 clock pulses individually. Correct? So 3 megahertz of frequency is nothing but the continuation of the signal will be very interval will be very small. Okay, so can you tell me the difference between the first square wave pulse and the second square wave pulse? It's not exactly the square, just imagine this is a square. Yes, what is the difference between these two diagrams? For this one and this one, what is the difference? Yes, unmute your mic and answer, Karthik. What is the difference between this signal and this one? So the frequency, the number of cycles is here is 3, okay, and the number of cycles here is we have 7. When I increases the frequency, the number of execution level will get increases. Okay, this is the point. So we have 7 clock pulses over here, so I can execute 7 instructions individually. Here we have 3 clock pulses, so that I can execute only 3 instructions. Okay, which is faster. This is less frequency and this is high frequency. which is faster in executing the results. This this one definitely increases of frequency while increasing the speed of execution. Okay, so that is why recent upgradation of the processor requires more frequencies. Okay, so next the pin on the chip can be grouped in 6 groups: address bus, data bus, control and status signals, power supply and frequency, external initiated signals, and serial input output ports. Okay, these groups are important in the architecture of 8085. And next comes the bus structure. So what is buses? Buses are nothing but it is a medium which transfers the data from one block to another block. Correct. We have more functions or more blocks like accumulator, temporary register, B register, C register, timing and control, decoding operation. Okay, so many blocks are there in the architecture. So the data from your ALU to memory or memory to ALU or the results from ALU to accumulator, all these are done by the buses. Okay, we have three basic buses. One is address bus, control bus, and data bus. All these buses put together in a single name, which is said to be a system bus. Okay, so now here this is your 8085 microprocessor, which is connected with the buses. So already we know we have A0 to A15, so 16 buses, 16-bit bus, and we have 8-bit data lines. Okay, address lines will be 16-bit and data lines will be 0 to 7, that is 8-bit. Okay, so here we have bidirectional one which carries data, and here we have unidirectional one which carries addresses. Okay, the transformation or transferring of data is only possible between input output devices and memory with the help of your microprocessor. Right, so this is your address which is connected with memory here and also with input device and output device. Okay, so here the data is supposed to give to all the devices blocks like memory, input, and output. Okay, and the control signals are also given to all the blocks. Okay, in order to read or write the data, the control signals to be supposed to be given to all the blocks. Okay, so this is bus architecture. And next comes we have address and data lines. I have explained you everything in the previous slide itself. The address bus has 8 signals, that is A8 to A15, which are unidirectional, and the other 8 address bits are multiplexed with the data bits AD0 to AD7, which is bidirectional one. Okay, so we have A0 to A7 and D0 to D7 at the same time because it is multiplexed with each other. Okay, we have to separate address and data with the help of latch, that is said to be address latch enable. Right, and next control and status signals. So control signals, what are all control signals? We have address latch enable, read signal, write signal, input output, and memory. Okay, and status S0 and S1. This is the status signal. Excuse me. This status signal S0 and S1 is to specify the kind of operation being performed. Okay, so it is similar to your flag register. Depending upon the operation done by your processor, this status signal will get set or exit. Excuse me. Okay, what is active low? Active low signal is nothing but whenever you give the low signal to my read pin or write pin, it will get activated. What do you mean by low and high signal? low signal is nothing but low we are going to give 0. Okay, low in binary we are going to give 0. In case of microprocessor, it is equivalent to the signal ground. Okay, this is equivalent to the signal ground, 0 or ground. And what do you mean by high signal? What do you mean by high then? High is nothing but low 0 na high enappa varum binary la.
Ma'am, 1.
Super. So 1, which is again equivalent to VCC. What is VCC? Supply voltage. Okay, what is here supply voltage? This is 5 voltage. Okay, the operating power supply of 8085 is 5 voltage. So plus 5 voltage kudtana, that acts as a high signal. If you go with 0 or grounded, that acts as a low signal. Okay, so your read and write signal is active low. Low is indicated by the bar over the signal. இப்படி கொடுத்திருப்பாங்க. RD bar, WR bar, IO/M bar. Okay, this is M bar. IO/M bar, which means when I'm going to give one signal to this particular pin, input-output operation will be taken place, and when I'm going to giving 0 to this particular pin, your memory operation will take place, right? So this is what the functions and operation signal to my control signal. Okay, active low the sense I'm going to give 0 to this particular pin to get into action, that is active low signal. Okay, so this signal these are all the signals coming under your control and status signals, right? And next, frequency control signals. So frequency control signals, there are 3 important things in the frequency control group. Okay, so they are X0, X1 and clock out. Okay, so X0 and X1 are the inputs from the crystal or clock generating circuit. So I told you that we are having no inbuilt clock signal generator to execute my instructions in the processor. So what I have to do is I have to go for external clock supply. Okay, external clock signal generator, which is connected with my 8085. Okay, so I'm going to take crystal oscillator. As you people are aware of crystal oscillators are used to generate frequencies. Okay, so clock signals are supposed to tune to my processor to execute my instruction. So I'm going for crystal frequency oscillator. So that is given in the pins or in the function X0 and X1. Okay, so the frequency is internally divided by 2. So the frequency what I am going to choose with the crystal is 6 megahertz. Okay, internally it is divided by 2. So the required frequency for my 8085 is 3 megahertz. So if I choose 6 megahertz of crystal, I can easily get my 3 megahertz internally. Am I right? Right, so this is your running clock at 6 megahertz of frequency. I'm going to get 3 megahertz of frequency by divided by 0 internally, the division operation done by your processor. And the clock out signal, so this is the pin which is used to drive the clock of the rest of the system. Okay, so rest of the system will be run using this clock out. So 3 important pins of X0, X1 and clock out. Clock out is used to execute the rest of the functions, right? Right. So next comes we have multiplexing. So demultiplexing and multiplexing. Multiplexing is nothing but combining one or more signals with each other. That is multiplexing. Demultiplexing, dividing the combined signal into individual one. Okay. From the diagram, you can easily understand here we have 8085. This is the control pin address latch enable. I told you earlier that this is address latch enable, which is used to separate data and your address. We have only 8 bits in multifunction format. In 8085, we have only 8 bits in multifunction or multiplexing format. I'm going to separate or I'm going to extract the data and address individually with the help of ALE. Okay, so my address lines from A8 to A15 is individual, so I have taken out individually here. Correct. And next comes I have data and address combined with each other from AD0 to AD7. So I'm going to separate this as address and data individually. So this here we have latch. This is the block which separates address and data. Okay, after the latch we are getting addresses, that is from A0 to A0 to A7, and the data will be separated from D0 to D7 with the help of latch. Okay, how this latch will execute or get into active state with the help of ALE control signal. This is the control signal for separating your address and data. Is that clear? When this particular ALE goes low, the address is saved in the AD7 to AD0 lines. That can be used for that purpose as bidirectional data lines. Okay, ALE is active low signal, like your read and write. The low panna mattum address and data will be get separated. It will not work. Okay, this is how we are demultiplexing the address and data from AD0 to AD7. Do you have any doubts so far? You can ask me questions or doubts then and there. No doubts? Shall I proceed? Right. Next we have cycles and states. Okay, so as we have discussed frequencies little bit before, 3 megahertz of frequencies is used to execute instruction in 8085. So here we have some cycles and states. Okay, so these states, machine cycle and instruction cycle, all these are belongs to frequency. Okay, T state is nothing but one subdivision of an operation. A T state lasts for one clock period. One clock period timing state. T state is nothing but timing state. It lasts for one clock period. Okay, so the instructions execution length is usually measured in a number of T states. Say for example, if I go for some A comma B, this instruction requires 4 clock cycle. Write A comma B, this instruction requires 5 clock cycle, that is T states. Okay, this is how it will be represented. So time T states is time and state, which is usually measured the number of length, the execution length is measured using this T states. And machine cycle is nothing but the time taken or time required to complete one operation of accessing memory, input, output, or acknowledging an external request. Okay, or operation முடிக்க எடுத்துக்கிற time machine cycle. Or instruction execute பண்றதுக்கு எடுத்துக்கிறது T state. Okay, and this cycle may consist of 3 to 6 T states. Okay, T state 1 clock period, that is T state. Machine cycle combination of T states. 3 to 6 T states are required to execute one complete operation. Can you see the difference? Okay. Next, instruction cycle. The time required to complete the execution of an instruction. Okay. So execution varaikkum mudikkiradhu instruction cycle. Access பண்றதுக்கு எடுத்துக்கிறது machine cycle, execute பண்றதுக்கு எடுத்துக்கிறது instruction cycle. Okay, so in 8085 the instruction cycle may consist of 1 to 6 machine cycles. Can you see the difference between T state, machine cycle, and instruction cycle? T state is smaller. Machine cycle is small. Instruction cycle is larger than the machine cycle. Okay, say for example, inside your instruction, it is like a Venn diagram. I will explain it like this. Okay, say this is your T. Okay, this is your M, that is machine cycle. Okay, and this is your instruction cycle. Okay, this is your instruction cycle. So what I'm going to explain you now is This is your time, that is t state, 1 clock period. Okay, so 1 clock period is very smaller than m and I, machine cycle and instruction cycle. Am I clear? And for machine cycle, we have number of t's inside. Okay, for one machine cycle we have number of t's inside, and for one instruction cycle I am having more machine cycle, number of m cycle. Correct. This is 1 clock period. This is 3 states or 6 states. This is 3 to 6 or 1 to 6 machine cycle. Instruction cycle comprises of many machine cycles. Machine cycle comprises of many t states. T states is nothing but it is a 1 clock period. Simple. Okay. So this is the relation between your timing, that is timing state, machine state, and instruction cycle state, right? And next comes we have generating control signals. How we are going to control, generate control signals with the help of some gates. Okay, you already studied digital electronics in your previous semesters, younger semesters, right? So here we have control signals like read, write, input, output. That mark is represented as comma, or it's represented as bar. Okay, what is the bar? Bar is nothing but this particular function will get into active low. Okay, for operation, this particular function will get into active low state. IO slash M bar, read bar, write bar, all these signals are active low signals. Okay, this is what given here as like this. So all these 3 pins are connected to my NAND gate along with my inverter. Okay, each and every output of this particular gate will is memory read, memory write, input output read, and input output write. Okay, the combination of memory and input output devices with read and write operation will be separated with this help of logic diagram. Okay, this is your logic diagram. Understood? Understood or not? Okay, so based upon the input given zeros and ones, the NAND gate will use me the output and it will execute the particular function as memory input, memory or input output read write operations. Okay, the combination of these three. That is what output of this particular logic cell here. So input output. Say this is input output, read or input output write, memory in read or memory write. Okay, 4 functions can be possible using this logic diagram. So this is how we are going to generate the control signals, right? And next comes I have explained you most of the basic concepts of 8086. Now we are going to look at the ALU. Okay, so the ALU is nothing but arithmetic and logical unit, which is used to do the process using 8086. All the computations are done using your ALU. Okay, and ALU includes a temporary register used for holding data temporarily during the execution of the operation. Okay, we're also having some additional register called temporary register near your accumulator and ALU. Okay, that is used to store a temporary register. We'll see this slack register in the next class. I hope everyone are clear with the basic concepts of 8085. Do you have any doubts? So that I can explain you, or once again I can clear your doubts. Any doubts? Any doubts? Navin Prasad. Naveen
Ma'am?
Prasad.
Yes, ma'am.
Yes, Naveen Prasad. Yes, Naveen
Ma'am,
Prasad.
sorry.
What did you understand from his class?
Ma'am, echo ಅಡಿಗೆ.
What did you understand from this class? Just what did you understand, Tanga? Summarize today's topic at least. Naveen Prasad? Or put your answer in the chat. Let me check. Some background noise is being heard continuously. I don't having that issues. It's not me. It's not me.
Ma'am, frequency of 8085.
Okay.
Audio
Very good.
back.
சொல்லுங்க. You proceed away. Frequency of H, right. And what else we have seen? Saran A. Saran A. Saran. Okay. Rajeshwari. Rajeshwari. What is the operating frequency of 8085, Rajeshwari? What is the operating frequency of 8085? Question is for Rajeshwari G.
Ma'am,
Yes, da.
3 megahertz.
Good. Very good. Sounds good. Thank you. Right, so far you people are clear with the concepts of 8085. So if you have any doubt, ping me. Okay. You can leave the class. Thank you. Thank you all.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.